All right, welcome everybody to my talk, Crafting Excellence in Manufacturing. How do over 100 finished products, 300 variants, up to 3,000 components, serial number traceability, and bill of material levels up to 12 levels sound to you? Sounds like complex manufacturing, right? Today I would like to show you that this can be achieved with Odoo 100% with a case of a project we were able to implement together with our partner Dectris. If you'd like to see and hear more about the business side and the project side itself, I would highly invite you to rewatch the talk done by my mate Marcus Williman this morning, who did a talk about complex manufacturing from their side of view. So, if you're ready, buckle up, strap in, and let's deep dive into manufacturing. If you have any questions, I already give you the QR code so you can prepare everything. All right, I will show it again at the end of the talk. Okay, perfect. My name is Andreas Hochuli. I'm a business analyst and consultant at Camptocamp. I'm focused on the Swiss-German market, and my specialties are supply chain management, logistics, and manufacturing. The topics of this talk, I would like to give you a little bit of context about the company we are looking at, the challenges which we faced, and then would like to go into the bill of material structure and later on into the details about many variants, multi-level BoM of materials, iterative manufacturing, agile work order replanning, multiple products from one manufacturing order, and I promise you a little cherry on the top for the end before we start into the Q&A. Dectris is a Swiss engineering and manufacturing company. They have their in-house development and manufacturing of high-performance X-ray and electron detectors. You can imagine these machines being kind of like a high-speed video camera, but instead of taking pictures, which you can look at, they record X-ray and photons and then supply this data for further analysis in research and laboratories. They have their own silicon wafer production on one hand, which is happening in a clean room environment, and on the other hand, they have a component assembly and a testing facility. And the goal of the project was to replace multiple software solutions with Odoo. So not just manufacturing, it's also the whole flowers like accounting, sales, help desk, and so on and so forth. But we are focusing on manufacturing in this talk. So we ended up implementing Odoo 15. Odoo 15's part in manufacturing is to plan and manage manufacturing itself, to lead the manufacturing process, and to provide instructions and do quality checks and to QC steps throughout the process. On the other hand, we have a manufacturing execution system. This one is linked and hooked up to all the manufacturing machines, is caring about managing the technical data, the technical side of manufacturing, and also collecting test results and data from these machines. So, many product variants, one of the challenges, as we are already introduced. Then multi-level bill of materials. We are talking about traceability throughout the whole stack of manufacturing levels. A yielded production. If we look at the wafer manufacturing, you're starting with a raw material wafer, and you have single chips. On this picture you see is about 50 chips on one of these wafers, and during the manufacturing process and all the steps you take some of these chips can become corrupt, or they don't make it up to the high technical standards and have to be scrapped later on. And we are also dealing with subcontracting certain manufacturing steps within the whole process. Then we had another challenge, which is long-lasting manufacturing steps. It's not like you assemble something 2 minutes and you're done. There are some testing and burning processes which take up to hours, days, or even up to weeks until the whole process is finished. So we needed to split up all this manufacturing a little bit better. Then you have a challenge which is called iterative manufacturing. So we had to repeat certain operations in case such a test fails and has to be restarted or redone, or something has to be exchanged in the assembly and later on tested again. So if you're not complying to the specs, we have to rewind and repeat certain operations. We also need to manage this changing work center occupancy. As you can imagine, if you have to redo a test which takes you 2 days, the work center is occupied more than you initially accounted for. And at the same time, you have to adapt your work order planning according to these situations to still make up for the final delivery date you promised to your customers. Last but not least, multi-product wafers. What you can see here is a wafer with multiple different products on them. So you start with a single piece of source material, and in the end you end up with different products manufactured out of one silicon wafers, or you manufacture multiple quantities out of one single piece. So, don't worry, you don't need to understand all the details. It's just to show you that we are dealing with high complexity here with a 12-level bill of material. From the bottom to the top, if we are talking about levels 12 up to 6, we are in the silicon wafer processing environment. And then further up, we go into electronics and mechanical assembly and testing, and from the levels 5 to 1. And then on top, we have kit completion, where we have the central detector and assembly, or putting it together with all the assistant machinery which is used. So many product variants, multi-level bill of materials. As I said, over 300 different variants means that some processing can be completely in-house with 2 steps, and others need to be outsourced maybe to have an additional step, another additional process done in a different subcontractor and get back in to continue, stuff like that. And at the same time, we need to fully trace all the serial numbers we are using for the manufacturing from the raw material up to the finished product which is fully assembled. If you look at this example of the silicon wafer manufacturing, you can see that we have a raw sensor wafer which we are processing up and until we have the finished sensor wafer, which is then so-called diced, which means it is made ready, cut into pieces, so you can retrieve the single dies from this wafer. So in order to achieve this, we couldn't just simply use different operations in one manufacturing order. This whole operation here takes weeks. We had to split it into more digestible, smaller manufacturing orders. And we needed to link these manufacturing orders through make to order. So we can now request a diced sensor wafer, and this will then concatenate the whole chain down to the sensor wafer and create manufacturing orders for each different sub-product. The answer to all of this is a little development which is called lot number propagation, because as you can imagine, we start with a sensor wafer which is lot number tracked, and in the end we still want to end up with the same lot number on the finished product. What we developed is we can configure a lot source component where we say that's the component we want to take the lot number from. And then the serial number is automatically propagated to the finished product throughout the manufacturing operation. And the best of all, we also made it work for subcontracting. So you can send out your wafer with serial number X. It is processed on the subcontractor's location and you receive it back with the same serial number you started with. This is one of multiple small developments which is available in the OCA as an open source module in the manufacturing repository. Some of the modules are currently in pull request state, so you have to search maybe a little bit, but they will all be available soon. And currently they're available in version 15. Topic: iterative manufacturing. As I said, we assemble a product, then we calibrate it, we test it, and maybe the test fails because of a single component which we need to exchange. So we need to backtrack and repeat all the steps with calibration and testing to reach the final result which we are looking for. How can we do that? It might be a little bit obsolete in the future. As we have seen in the keynotes in the morning, you're now also able to do a similar thing, but I don't know if Odoo Standard 17 can do it the way we implemented it for Dectris. So what we do is we created a wizard where you can choose from all the different operations you have in your bill of material, and you can select in which position you would like to re-inject the same operation again. If you do that, you create a copy of this operation, including all the quality steps and all the quality checks, instructions, and so on, which are tied to this operation. And the operation or the manufacturing or the work order is then also tied and linked to the previous and the subsequent work order, so everything is back on track again and can be continued. Also, we update the planning from the position we introduced this work order, so everything ends up nicely on the timeline later on. This is also available in the manufacturing repository. It's called MRP production inject operation. Agile work order replanning. As I explained, a lot of things happen throughout the day when you're manufacturing, especially if you have to repeat stuff. So we need to account for work center occupancy. We have bound resources which cannot be freed again for the next work order, and we need to be able to plan dynamically. The answer to this was also a small development which we called lock work orders. The idea is that first we plan a longer process time than is actually needed to just simply follow through this work order, because we have to account for a little bit of backlash and a little bit of repetition. So our planning is not just overthrown from the first second we start actually manufacturing. Second, we manually replan work orders throughout the day. As soon as a resource gets freed earlier, we can replan another work order. We can shift work orders of other manufacturing orders around. But once we have set the planning, we can now lock this particular work order in place by using this little lock icon. And from this time on, the start and end time of this work order stays in place. And we can replan around this work order without any issue, also automatically replan, and we always respect the position and time of this particular work order. This development is called MRP work order lock planning, which is also available in manufacturing. And you can see we can use it in the back end on the work order tab in manufacturing orders, or as well on the planning tab where you have the overview of all the work orders. Multiple products from one MO. So I don't know if some of you already experienced this. If you take a single piece of component and you manufacture serial number tracked products out of it, what happens is Odoo will split the manufacturing order after each serial number is created and each piece is manufactured. So you end up with fractions of a single piece, which doesn't make Odoo happy, and you will get bombarded with error messages next time you try to reserve this leftover piece of component. So this is tricky. Also, what we wanted to do, which you can see on the right-hand side, we are manufacturing multiple different products out of one component, which is not possible with pure standard. However, if you leverage byproducts, you can achieve this. So, first of all, we can create different products as byproducts, and Odoo won't care, it won't split any manufacturing order, and you can manufacture as many serial number tracked products as you like. At the same time, you can also manufacture multiple different products at the same time. So what you need is, you need to use a dummy product as the main product, probably a consumable which will just disappear and you don't care about it anymore afterwards, and you use actual byproducts for your finished goods. There is one little culprit, which is you cannot procure these byproducts automatically, which means if you have a need of this byproduct, it won't automatically reorder through this manufacturing rule or through this manufacturing order. We looked into that. We didn't need it for this project, but it would be a little development to make it possible to also procure byproducts. And I promised a cherry on the top. Here we are not talking about manufacturing, but a very close topic. Consumables. Consumables also need a home. If you're working with consumables, doesn't mean that they just disappear physically when they enter your warehouse. You still need to put them somewhere, and the other guy which needs these components also needs to know where to take them from. So using put-away rules, this works quite nicely for put-away. Odoo will guide you to the to the final location of this product. But once you want to retrieve this product, since there is no stock there physically, it won't know where you can take it from. A small development in the logistics, stock logistics workflow repository makes it possible to use the put-away location to use as the source location for picking, which helps you taking the consumables from where they actually physically are. Okay, I would like to finish my presentation. I thank you for your attention. If you have any questions after the talk or after the Q&A, don't hesitate to contact me directly. Also come to our booth. Also, Dectris is highly interested to talk to you if you would like to share some ideas or share problems with manufacturing in Odoo. And I would like to open the Q&A session.
Thank you. Basically, I've got a lot of questions. I will start from the bottom. Have you integrated the homegrown MES system with Odoo?
No, it's currently only semi-integrated in the way that we can extract database information which we link to the same serial numbers or to IDs and then interact manually with this data, but it's not fully integrated into Odoo.
Another question, what is the OCA?
So the OCA is the Odoo Open Source Community Association, where we share code, completely open source. Everybody can contribute, and they have a booth, I think, in this hall even, where you can talk to the guys and get in contact if you're interested to use or share code.
I've got a question about the different levels that you can have for the BOM. What's the maximum number of BOM levels you can manage, like for example, like a car? Is it possible or not?
I wouldn't know of any limit in terms of BOM structure. I'm not sure if the standard tools will be easily usable if you go into depth of hundreds of levels, but in theory, the database model would certainly support that.
There is a question related to this. Can you compare two different BOMs directly from Odoo?
Compare in the way of what the differences are.
I suppose like on the same screen to see the
No,
different
not that I
components?
know of.
No? Maybe not yet.
Maybe not yet, yeah.
So it's a question here, but not for the BOM. How easy is the fiscal localization in Switzerland?
The fiscal localization, how easy? Maybe to get on with other topics regarding manufacturing, I'm happy to talk with you about that after the talk, to get into details.
Yeah, it was a tricky question.
Okay.
Do you want to answer a last question?
About
Yeah? No, not for that. Handling multiple products from one MO with the byproducts is super smart. Oh no, congrats.
Oh, thank you.
I see. It was just a settlement. But therefore, we've got the last question. Where could you find the lock work order module?
As I said, it's in the manufacturing repository of the OCA. It might not be merged into the main repo now, but look for open PRs and you will find the code there. As I said, it's a MRP lock operation or work order, if I remember correctly.
Oh, well, if you don't have any more questions, well, thank you so much. It was super impressive. Thank you.
Thank you very much. Have a good OXP.